Hi everybody. I want to cover a very quick topic here, which is the process of eutrophication, which is a type of water pollution. Hopefully I won't go off on a rant as usual or a ramble, and I can keep this quite concise. The process of eutrophication I've put above my head, and you can see that I've numbered it because it happens different steps in this order. So if you take anything away from this video, please try to remember those steps in that particular order. That's important. Okay, so eutrophication, it's a similar outcome to what we talked about in the previous video about what happens when organic pollution gets into water. The end result is that bacteria grow and take oxygen out of the water and can basically kill everything that lives in that water. Eutrophication has a similar outcome, but it's not the same because it has a different source, and ultimately the steps are different in what happens. So don't confuse or conflate the two things, please: organic pollution and eutrophication. The source of eutrophication is not organic molecules, it's inorganic compounds, specifically nitrogen and phosphorus, or if they're dissolved in water, we call them nitrate and phosphate. Those are the main ingredients of synthetic fertilizers. So therefore, the source of eutrophication is ultimately fertilizer that humans put onto land, or it can result as well from animal poop. Okay, these are the steps that you can see above my head in a little bit more detail. So I'll just go through them one by one. All right, so the first step is water receives nitrogen and phosphorus, or in its dissolved form, nitrate and phosphate, from too much fertilizer added to the land. This might be a good point to go back to the water cycle. You might remember that there's different routes that the water can take. Remember, it has this dissolved fertilizer in it. It can percolate through rock and eventually maybe enter the water table, or it can flow across the surface and enter water bodies. We're interested in the surface flow because of what happens next. Okay, so this water containing nitrate and phosphate can get into rivers and ultimately lakes. We're interested in lakes more than rivers because in rivers the water is moving. It can flush out the pollutants to other places, move it to other places, and also because that water in rivers is moving, you don't have the same problem as loss of oxygen that you do in still water. So in lakes, the nitrates and the phosphates can build up and lead to the next stages. Okay, so in slow moving water, like lakes, the next stage is because of all of this extra nutrients, algae grow, and we call them algal blooms. Okay, one of the outcomes of this is that these algae, or sometimes the old-fashioned name we might use is blue-green algae or cyanobacteria, they start to grow and they can produce toxic byproducts. Where I'm from in England, I lived near a few lakes, and in summer you'd see signs go up that said, "Don't allow your dog to swim in this lake." And the reason for that would be the toxic chemicals produced by the algal blooms. Okay, so that's the first stage. It might not be too bad in itself, but it leads to other steps. Step 3, because of this increased concentration of algae growing on the surface of the water body, it cuts off light that's able to pass through the water column. And that means that plants growing on the bottom of the lake begin to die off because they can't photosynthesize. They can't get enough light to photosynthesize. Once these plants have died off, the dead plants start to decompose, and that means that the next stage is bacteria start to grow on this material, on this dead plant material. And ultimately, that leads us to the final stage, stage 5. There's so much bacteria growing on the bottom of the lake on this dead plant material that they take oxygen out of the water, and that means that the water becomes anoxic. It has, and the sediments. It means there's no water, there's not enough oxygen or dissolved oxygen in the water to support life, and ultimately that means that everything in the lake will die. That's the last stage of eutrophication. Okay, I hope that made sense. Just a few things we can say in support of that. The symptoms of eutrophication, what you might be able to see if you suspect that a lake is becoming eutrophic. Well, first of all, you can see algal growth on the surface, increased turbidity, or the water starts to obscure itself. Because of the death of plant material and algae as well, you might start to see increased sedimentation or increased levels of mud on the bottom of the lake. If you were able to measure dissolved oxygen, you would be able to see dissolved oxygen levels going down. Because of decreased oxygen levels, you would be able to measure decreased biodiversity, particularly of primary producers in your lake, and the loss of submerged, well, macrophytes is large plants, the loss of large plants growing on the sediment of the lake. You might see algal blooms that I've already said, and you might be able to measure the increased toxicity produced by them. And then ultimately, you'd start to see effects on the upper levels of the food chain. You start to see a decreased level of consumers, especially fish. Okay, these lakes are obviously eutrophic. You can see algal growth. This one is like a thick soup of algae. You can see this woman pouring out algae from a beaker. But ultimately, the last stage of eutrophication could be that you get very, very clear water. And often there's a misconception that a very clear lake, like this beautiful one here, glacial lake, is very pristine. It might be the opposite. It might look pristine because there is nothing alive in that water anymore, because the dissolved oxygen levels are so low. Okay, and then my final slide, what are the impacts? Well, first of all, eutrophication is a symptom of farmers, especially putting too much fertilizer onto the land. So that could be a huge economic loss. There's no point putting large amounts of fertilizer onto land if the majority of it is going to be washed away in surface water. So farmers need to be careful about adding the correct fertilizer at the correct time. They need to avoid the rainy seasons to try and avoid that washout. There can be health effects from drinking water that's rich in nitrates. So in some cases, the water bodies that are affected by eutrophication might be reservoirs where water is taken for human consumption. There's a bit of controversy in the science about what that actually causes to human health, but it seems like it could cause increases in stomach cancers and blue baby syndrome, where babies are born with very low levels of oxygen. So there's a public health potential problem there. Eutrophication, I've already said, can lead to loss of water bodies, not just because you can't allow your dog to swim in the water, but it's dangerous for humans as well, in terms of the toxic products produced by algal blooms. And finally, and possibly most seriously, the huge loss of biodiversity to that water body that eutrophication can result in. Okay, so I hope that was helpful. And as I said at the start, if you can take one main thing away from this video, please try to remember the order of what happens in eutrophication from those key terms above my head. And again, please don't confuse eutrophication with organic pollution. Like I've said, they're similar effects, but from a different source. Okay, hope that was helpful. Take care, everybody, and I will see you in our lesson. Okay, bye-bye.